Again, my name is Josh New. I'm Director of Policy at SeedAI. I will be emceeing a lot of this event, but I'm also very excited to participate in the programming itself with a topic that is near and dear to my heart and near and dear to the heart of SeedAI. We run a coalition called Accelerate Science Now, which is 80 plus of the world's leading organizations that are all in the United States focus on the opportunity to accelerate scientific discovery around the potential of AI and other emerging technologies. We have 3 wonderful representatives of member organizations that are part of this coalition, but also they are devoted to this work and leaders in their own right. So we just heard from Erwin from the National Science Foundation, who is running this incredible new Tech Labs initiative. We've had a lot of folks today talk about the Genesis mission at the Department of Energy. We've had folks talking about fully automated labs and AI scientists, and it certainly feels like we're in sort of a renaissance moment for American science. And people are starting to make some really large bets on this actually paying off. Lots of money, lots of people, lots of resources. And we're not just doing science differently, or we're not just using AI to do science. We're thinking about how to do science entirely differently. We're going to do more science, and I'm stealing a line from my parents. We're doing more science and different science. So we're going to get into all of that and more, but want to introduce our wonderful panel here today. From left to right, we have Caleb Watney, who is co-founder and co-CEO of the Institute for Progress. We have Anastasia Gamick, the co-founder and president of Convergent Research. And we have Jean-Paul Chretien, the director of the Big If True Science Accelerator at Renaissance Philanthropy. And first, I want to apologize. In the hand cards, I misspelled Renaissance. And I swear to God, I know how it's actually spelled. But this is focused, I guess, on STEM rather than English language arts. So we're just going to roll with it. Before we talk about the future of American science, let's talk about what science is today, or maybe what it was like a couple weeks ago, a couple months ago. You're all focused on fixing or improving different parts of this ecosystem, and I would love to hear from all of you about why you think this needs fixing. What is the status quo, and why is it not working in a way that makes you particularly motivated? And so we'll just go down the line.
Sure. Thanks, Josh, and excited to be here. As Josh mentioned, I'm from the Institute for Progress. We're a nonpartisan think tank. We do a lot of work on tech science, innovation policy, and in particular, one of our big areas is meta science, the science of science, basically trying to take the attitude that in the normal enterprise of science, we have a hypothesis, we run an experiment, and then we use the data that we learn from that to kind of update our processes or hypotheses over time. And yet maybe my single biggest critique of our current system is that we're not applying that same sort of scientific mindset to the way that we fund and structure science. In the 1960s, we kind of had this moment where we created a series of really amazing, cutting-edge public science funders, especially the National Science Foundation, the National Institutes of Health. And there is so much tremendous good that has come downstream of those investments. But there were particular decisions about the way that grants were structured, the way that peer review worked, the way that we decided which kinds of scientists would get funding, what the process for that would be like, that were themselves actually just kind of judgment calls at the time and may have been appropriate for the way that science was operating at the time. But the underlying productive structure of science is actually changing. We've seen sort of in this meta-science literature the rise of team science. It's no longer about for one lone genius working at a chalkboard, maybe supported by a grad student or two. Increasingly, frontier discoveries are coming from teams of interdisciplinary sciences working in a close collaboration and also working with tools that are much more infrastructure intensive than they were in the past. And so given this kind of underlying change in the way that we know frontier science is operating, I've been a little bit frustrated that the way we fund science and the mechanisms and institutions of science have not been keeping up and have not been actually applying this kind of scientific mindset to the way that we fund and structure science. So I would love to see kind of a much bigger, bolder attempt to try new ways of funding science, and then most importantly, actually trying to be scientific about the way that we're doing this. We can run experiments on the way that we fund and structure science. We can try different ways of running peer review, different numbers of reviewers, different grant amounts, different time processes, and change the incentives in the process that we're kind of having all these scientists run through. And I think we could end up getting enormous returns. We're sort of in a period where budgets are much tighter than I think they were in the past. But collectively, we spend as a federal government close to $200 billion a year on R&D. If you can even make that 5% more efficient, and I think we could do dramatically better than 5%, that is billions of dollars of additional science funding that we could unlock without actually spending $1 more. So that feels very motivating to me.
sometimes I take umbrage with like science is broken. I don't actually know if science is broken. I think that individual investigator, curiosity-driven research is really amazing, and they find amazing things and amazing discoveries. I also think that industry in the US, startups, our big tech companies, our big industrial partners do an amazing amount of R&D, but they tackle different sets of problems. There's a set of problem where you need a coordinated team, something like 5 to 25 people, working on a very specific set of technical milestones to build kind of an unlocking technology. Think something like the ability to map the human brain, or measure how much carbon is removed from the atmosphere by the ocean, or even build like an open source software language. These are all team projects that need a direction and they need an end goal, and you can't do them in academia, largely because they have a bad dollar to paper ratio. You're not gonna like justify your next grant or your next publication by doing 3 years of hard engineering work, and they're public goods, so they're not gonna be done in industry. And so we've been looking at sort of the landscape of these bottlenecks and these gaps, and building what we call focused research organizations, which are startup-inspired R&D efforts meant to specifically tackle these problems. So if we think we want to map the whole human brain, right now that should cost $1 billion, unless one of you has $1 billion, in which case please come talk to me. I think it's something
Raise your hand.
I think it's going to be really, really hard to map a whole human brain. But if we can get that down to $100 million, well, now that's like a large funding effort and a reasonable amount of money to spend on a scientific endeavor. And that tool development we're working on at a FRO called E11 Bio. They're based in the Bay, they have a lab, they act and they think just like a startup, but they're doing this nonprofit R&D mission. Yeah, so that's kind of, I am excited about more different science, and these focused research organizations are one new way to organize science, and you guys heard from Erwin, I'm really excited about Tech Labs as a parallel into FROs.
Yeah, so picking up on those comments, I think we're underinvesting in a couple of things, and one is a category of really important, potentially very impactful research that's not a good fit for academic grants or for startups. So we're really good at funding research papers. We're really good at funding startups that have great ideas for commercialization. But in between, there's this category of R&D that's potentially really impactful, that's developing field-level capabilities that we don't have enough good models for. So, you know, the data sets that's going to lead to the next AlphaFold, the research tools that's going to allow new types of studies and new data, the platform technology that's going to develop not just one single drug, but a whole new type of drug that could be applied to lots of different diseases. So these are the things that require tight coordination, whether it's an interdisciplinary team or multiple teams working together, and that are going to generate community goods, public goods that others can build on. And the thing is, we know how to do this, right? We have focused research organizations as a new model. We have NSF's new initiative. We have DARPA, which has been doing this for almost 70 years, and so we're seeing more interest in those types of models in other countries and other organizations, which is really encouraging. But that leads to another thing that I think we're underinvesting in, which is the human capacity, the talent to run those sorts of programs, because these are skills that one doesn't necessarily pick up as a startup founder or as a very successful academic researcher. It's mapping a field, it's understanding bottlenecks, it's strategic planning about programming, it's getting the best teams in the world to work on a problem. And so DARPA, which pioneered this model of these coordinated research programs, has a real advantage because they've been at it for so long and they've got the resources to provide a lot of scaffolding, a lot of support. So when I was a program manager at DARPA, I had no idea what that involved, but I immediately had a team of PhD scientists and budget experts and contracting experts to take me through it. But other organizations, other countries that want to do more ambitious research, they don't necessarily have that scaffolding, and they're lacking the talent to do that. So I think training the people to run those sorts of programs is another area that could be really high leverage.
Fantastic. So, Anastasia, you mentioned the importance of FROs, Focused Research Organizations. I'm too like DC brained. I have to call it FRO in my head. I have to spell out the acronym. Convergent has described its approach as sort of like mapping the tech tree of science, tracing things back to the trunk, figuring out like what new part of the tree you could unlock that would unlock like whole new domains. And there's initially like a set number of these problems, you thought. What is an FRO-shaped problem? How many are there? Is there an upper limit? How much should we try and bite off here?
Yeah, so when we started, we thought there'd be a handful. My co-founder is a neuroscientist. He is out of Ed Boyden's lab and worked at DeepMind and Kernel. And he just thought, okay, there's like maybe like 5 or 6 orgs out here. Let's start a couple. And then we started running these organizations and interviewing founders. There's more than a couple, but I don't think it is like a boundless number. Maybe like 5 per major field of science. So I think we're looking at something like 200 projects, which is over the course of years in organizations, you can kind of pick off what the highest impact ones are, and it's a limited number. I think that an FRO-shaped project tends to be something that you could describe as like a product or a tool. Think like a large data set. So what if we open source the data set that was all of the FDA approved drugs against all of the druggable targets? That's just like a very singular data set that would enable drug repurposing. It would enable understanding what causes side effects, what causes potential harmful diseases, and then from there allows you to also train models on drug discovery and potential drug interactions. That data set is a product that you can describe pretty easily, and you can guess where advancements come from that. The same thing with the brain mapping microscope. We know how to build this thing, this product. We know what technology we need. It's actually really cool. So a human brain, sorry guys, has e to the 11 neurons running through it. Each one is incredibly small, and right now to map a brain, you have to use an electron microscope and follow each neuron all the way through the brain, which is why it's so expensive. Instead, we're using a light microscope, which is way cheaper. You use fewer slices. And the way we're doing that is we're slicing the brain, putting in diaper powder, they're gonna get mad at me, and then add water. And literally it's the same chemical that's in diapers, and it expands each slice. And so we know that we can combine AI, microscopy, and this expansion microscopy technology to make brain mapping cheaper. So it's a very clear product that then is on the base of what will be a bunch of downstream research. Things like understanding consciousness. How do reward signals get processed by the brain? What can we learn about building efficient AI, like compute efficient AI, from how mammalian brains already work? But we can't do any of that research yet because we don't know what the synaptic map of the brain looks like.
Amazing. I want to keep asking you like a lot of follow-ups, so we don't have so much time. So we covered FROs. JP, you mentioned DARPA model, other models. Caleb, you guys have done a lot of work to like sort of map out the menu of options for doing science for the federal government. Can you walk us through like what the tools in the toolkit are and how you actually decide which one is fit for like a particular scientific goal? And like, do we have enough tools?
Yeah, great question. And thank you for previewing. I guess to let the audience know, we have an upcoming tool that we're going to be launching in the next month or two called the Atlas of Innovation. Basically, the idea is that when the federal government or even when a philanthropist is wanting to fund some area of innovation, they want to see a breakthrough in area X. There's a really wide range of different kinds of financial tools or mechanisms or incentives you could use to do that. But I sort of worry that today that decision-making process feels very vibes-based. We're almost like reaching into a proverbial grab bag and choosing out a mechanism at random, whether it's an innovation prize or an advanced market commitment or maybe a new DARPA program. And each of these tools can be incredibly powerful when applied in the right kind of circumstance. But I think to date, there has not been a super developed kind of map of the territory. What are the different kinds of mechanisms that exist, and what are the attributes of a problem that would encourage you to choose one kind of mechanism? How do you know when it's fit for purpose versus another? Basically, what is the shape of a problem that lends itself very well towards an innovation prize as opposed to a loan guarantee or a DARPA program or something? And I think if we actually had a better developed map of these different kinds of financing mechanisms, we could encourage a lot more creativity in the way that the federal government funds science. Because today, it very much oftentimes collapses back to, well, we know how to do grants, we know how to do contracts, and actually in the Department of Energy, we do a lot of like loans, but there's not a lot of creativity kind of beyond that. I guess I would say this has actually been, I think, a really fruitful area that I've been particularly excited to see this administration kind of push forward is this kind of encouragement to use a broader set of funding mechanisms. I think just in the last month, NIH announced a new $100 million innovation prize, and I think BARDA did another $100 million one previously. But before those two prizes, kind of the largest ones that the federal government had done had been in the more like $20 million range. So this is like a 5x increase in the kind of like total scope of innovation prizes. So I'm just really excited about kind of utilizing this much broader sweep of different kinds of financing mechanisms, and be on the lookout for the Atlas of Innovation. I think it's going to be a really nice tool for this community, and we'd love to get feedback kind of on it as we continue to iterate it and update it over time.
Amazing, thank you. JP, so say we get the money, say we get the sort of programmatic creativity and mandate to do all these new wonderful things, there's still going to be a lot of barriers that we run into, right? So do we have the right data? Do we have like the compute credits? Do we have the right people in the room talking to each other? And do we have the people that like actually know how to execute here? And I want to focus on like the people challenge specifically. How many people do we have in the US, how deep is the bench that like, if they got the green light tomorrow could go do the thing, right? Say they got a $100 million blank check and could build their team. When does that run out? And then can the Big If True Science Accelerator turn out enough of those people?
Yeah, I think the bench now is not very deep, but it could be, because we think the skills that are needed to run efforts like that are teachable. And so we've developed this program with a curriculum based on, to a large extent, on DARPA experience, because that's where there is a lot of experience, but adapted to other sorts of contexts, mentorship with people who have run these sorts of programs. And so we think it's possible to give people on day one, when they show up at an organization like DARPA, like ARPA-H, or they want to start a focused research organization, they'll be effective. And we think that is the limiting factor, like the enthusiasm for new research models, more ambitious R&D, that's there. We see that in the US efforts that we've talked about today already. We see that internationally with other countries that want to set up organizations based in some way on DARPA. So UK has such an agency, Germany has such an agency. Netherlands recently announced they're standing up an ARPA-type organization. Last week,
NARPA, I'm assuming.
Last week, the government of Japan announced a new effort called the Global Startup Campus, which has an ARPA component. So, and on the philanthropic side too, we've catalyzed a renaissance philanthropy in less than 2 years, over $430 million to a philanthropically funded, ambitious R&D effort. So the funding is there, but the people are not necessarily there to lead those efforts. And especially for a country that's doing this for the first time, or an agency that has no experience with this, and they don't have this, this community to draw on that DARPA has, there's where we really see the potential for training to, you get into this reinforcing cycle where there's more ambition from the funders, and then they see that there's people there who can actually lead these efforts, and then they go and do great things, and it goes around like that. I want to give a quick shout out to a great piece that came out a couple of days ago by Jordan Dworkin on the Abundance and Growth Fund blog. It's called Who Will Program Manage the Program Managers? And it gets into this human capacity as a real bottleneck here, and some emerging evidence that this sort of training can actually work.
Amazing. So as I'm sure you all have noticed, we're at the American AI Festival. None of the things that you all work on is like an AI program, but AI is like very obviously creating the activation energy for this all to happen, right? Like it's not a surprise that the administration is talking about a golden age of innovation, that we have the Genesis mission and tech labs at the same time that AI is going like this. And so would love to hear your thoughts about like, the way that AI is enabling other sort of reforms in science, what it makes easier, and what it's like gives us the excuse to actually go do that we've been trying to do for a while.
It's interesting. I'm going to use a very odd analogy here. So in the 1970s, we had a period of very large inflation, famously. And immediately following that kind of inflation period, you saw a lot of systematic efforts to kind of like unbottleneck different parts of the economy. So you saw like large-scale airline and trucking deregulation. You saw large-scale reforms of other kinds of transportation and food and drug kind of issues. Similarly, kind of in this most recent bout of inflation, you saw a renewed focus on like dredging efforts. Like, why could we not ship so many things in the port? And the Foreign Dredging Act of like 1907 suddenly became headline news. And I bring this up to say that sometimes when you have large bouts of energy or attention in one area, it kind of ends up illuminating the bottlenecks in other parts of the economy. And so I think inflation almost has this like interesting political effect of making much more salient physical bottlenecks in the economy. And I think you can make an argument that like this renewed focus on AI is almost doing a similar sort of thing because there's suddenly so much growth in maybe like hypothesis generation of new ideas. It's making much more salient the bottlenecks in the rest of the productive process of science. And so we just heard some very interesting talks about physical embodiment of scientists. And we're seeing a renewed focus on cloud labs and automatable labs because suddenly things like how fast can you do pipetting is like actually the bottleneck for trying to figure out whether or not hypothesis is true. And so I think the best possible version of this is that we can utilize this newfound energy and momentum and also kind of this diagnostic effect of kind of making much more salient the bottlenecks and then have that be like a hyper-focused policy initiative to really attack those bottlenecks kind of one by one so that you can kind of unblock this chain. Because if all you do is just increase dramatically your supply of plausible hypotheses, but you don't do anything downstream, I think you're going to see pretty disappointing effects compared to what we all want to see.
I have two answers. So one, I spend a lot of time with my friends at Anthropic and OpenAI, and sometimes they're like, we're going to solve biology. And I was like, you've never seen biology. Biology in the world is really, really complicated. We don't understand how cells work, how signaling pathways work. We can't measure what's in the environment. There are lots of things that we can't sense. And that used to be kind of fine, because what were we going to do with that data anyway? I think that AI gives us an opportunity in science to launch new investigations into novel areas that are actually blocked by our sensing and measurement capabilities. So building new tools, new platforms, new big experiments will then allow us to use the capabilities that AI is generating. You can't actually just point an LLM in a body and be like, solve cancer. You need to understand how those cancer cells are forming, what processes are underlying it, and then point the AI and be like, okay, what are our experiments? And there's been no reason to develop those tools to date. And I think that now there is a real reason to push really fast on tool development. I think the other is that I really love seeing scientists become more and more ambitious. When I started talking about FROs 5 years ago, people actually kind of couldn't comprehend the idea that somebody might give them a small company and $50 million to tackle what they think is the biggest bottleneck in their field. And over the last 5 years, I've seen scientists just left and right out of the gate say, hey, I need to do this problem. I think that science can address this human need. I think that I can build a new organization that would be really impactful for these reasons. And so much of that is because of this rising level of ambition that I think comes a little bit out of these new opportunities and kind of, there are good things and bad things about hype. I think that this rising level of ambition is a good thing that comes out of hype.
I agree, and I think that's one of the great things that's come out of focused research organizations, not just the specific contributions, but this general raising level of ambition. So the folks that we see that we take into our accelerator program, some of them come in, they know what focused research organizations are, they have an idea that's a good fit for that, it's super ambitious, and they want to run with it, and we wouldn't have had that five years ago. I think there's a lot of opportunity for AI above the level of the bench, above the level of the laboratory, but at an orchestration level. So imagine an R&D program manager enabled by AI And so that could be useful for like a standard kind of academic research program. A program officer has got to manage a portfolio. But I think it could be especially high leverage for someone who's managing a very complex, ambitious effort, say at an ARPA-type organization, and trying to design a program around it. So this is mapping a field, this is understanding bottlenecks, this is talking to hundreds of scientists to understand what's feasible, this is designing a time-bound program and figuring out how to phase milestones. So some of this sounds sort of boring compared to automated labs, but this is like the art of DARPA is understanding how to optimize a program like that. And so, DARPA, again, has a great advantage because they have such infrastructure to draw on. But think about the country that has no experience with this, the agency that has no experience with this, Ministry of Health in a low-resource setting that wants to do more ambitious R&D. So there, I think AI at that level can be incredibly impactful and could test different designs, could simulate running entire programs, and de-risk that effort. You're going to commit tens of millions of dollars for this, and it'd be great to have done that in silico testing to give you confidence that you've got a sound design.
Great. So we've talked about the tech tree enabling, like meta enabling opportunities, but it feels like there's kind of no shortage of problems that we could be trying to solve. The Genesis mission has picked 26 problems. I heard that somewhere there's like 100 more on the cutting floor. The Tech Labs is going to pick a handful of focus areas. DARPA famously doesn't really like being told what to do by like civilian agencies or Congress. They like figure out their own priorities, which has worked tremendously well. But like in all of these situations, someone somewhere is deciding, what are we going to prioritize? What are we going to fund? What is worth putting to the top of the pile? How can we actually like improve that decision-making process so we know that we're actually focused on the right challenges? Is there a playbook here?
So I'll let Caleb talk about mechanisms. I think that there's a thing that really matters, which is finding people whose judgment and taste you really, really value and letting them make good, hard decisions. And so actually, like a lot of, in my opinion, a lot of the best projects that came out of DARPA, a lot of the best projects that came out of Philanthropy, a lot of the reasons that CEOs are able to build these amazing tech companies is because they're enabled to make good decisions and they are accountable to their outcomes rather than their inputs. And I think that that is a thing that we should enable more of. People making really good decisions about what is most pressing in their field or what is most pressing in a certain area. And then the question is, how do you develop selection mechanisms to select the best program managers, to select the best CEOs, to select the best decision makers, and have them be accountable to actually what they build and they achieve instead of to a peer review committee. Peer review is really important in many ways. It is also incredibly destructive because it just causes consensus and no one to move faster. And so how do you build systems that let people make good, hard decisions?
Yeah, I think this is tricky, and I guess I have a lot of hypotheses about kind of like what new selection mechanisms or how can you empower people to choose the right kinds of problems, but I think we should also be clear that like there's a lot we don't know, and this kind of gets back to some of the meta science points. I would love to run a bunch of different experiments of different kinds of ways of choosing projects and different kinds of prioritization schemes, and then kind of gather really granular data and kind of see over time whether we notice differences in one way of selecting projects versus another. One interesting idea that I think has like gotten some play is the idea of using golden tickets in the selection process. So one common critique of the traditional peer review process is that it ends up being sort of a lowest common denominator, like decision by consensus. Which is really the opposite of how like a lot of venture capitalists make decisions. You could imagine instituting a mechanism that tries to almost recreate some of that more like VC mindset, where you give each reviewer on the panel almost an anti-veto, an ability to say, only one time per cycle, I want to basically guarantee that this project gets funded. I feel so strongly about this relative to my peers that I really want to push this forward. And then you could track and see over time, how do the people who choose certain kinds of programs, how does their taste differ from others? And do we end up seeing that actually those projects were more promising over the long run? And so I think there's a lot of things we could test. The last thing I'd want to note here is that there's almost like a meta point here, which is that sometimes the decision maker doesn't actually have to be someone who works in the federal government. Sometimes what we want to do is actually buy the scientific expertise and judgment and taste of scientific performers later down kind of the pipeline. And actually, one kind of great advantage of doing things like focused research organizations or like tech labs, basically much larger amounts of funding to specific performers, is that you're basically empowering the decision makers there to make decisions. There's sort of a lot of questions about should we fund more project-based science or more person-based science, but actually everything at the end of the day kind of boils down to projects. The question is just who is choosing the projects, and sometimes it is a sort of decision by consensus through an NIH peer review, or sometimes it's like an empowered person at the ARC Institute or at the Howard Hughes Medical Institute, and I think it's like a totally legitimate thing that sometimes we want to actually empower specific groups outside of government. One nice example of this kind of more on the fellowship side is the Activate Fellowship. So this is a really cool program that basically empowers scientists, give them a couple of years to kind of experiment or try an idea before deciding whether or not they actually want to go down a commercial kind of route or where they want to pivot back to academia. And a lot of federal agencies, including ARPA-E and now NSF, have actually done Activate fellowships and cohorts. But they're not actually running the fellowship internally. They're basically betting on the scientific taste and judgment of the Activate team and then saying, we want to empower you guys to make decisions, and then we're going to hold you accountable to some kind of aggregate output thing. But I think that actually would be a more successful model than if they tried to just fully recreate the Activate fellowship internally. So I think that's just another way of thinking about scientific decision-making is sometimes you can actually push the decision-making down a layer in the stack, and I think that can be useful.
Yeah, I think the way not to do it if we're striving for breakthroughs is to give these decisions up to a panel and to peer review. I think that
this panel specifically.
Maybe this panel, Anastasia. But I mean that mechanism has arguably done pretty well in terms of generating incremental advances over time, and that's an important part of the R&D ecosystem. It's sort of like your savings account or your mutual fund, but you want some part of the ecosystem, I think, doing going for the big swings and empowering individuals or small numbers of people to make big bets. The other side of that, though, is that there's risk. And sometimes they will fail, and so I think that's something that needs to be acknowledged as well when there's interest in standing up a new organization or new model that's going to do this. There has to be an acknowledgement and a willingness to accept failure as the price for having those occasional breakthroughs.
If I could just very quickly, I think, plus one that. If I had like one takeaway, I think, for the audience in terms of like the one way to move science forward, it is to think in this portfolio sense. There is not any one good, true, and correct way to fund science. And even if there were, it would be a constantly moving target and shifting and changing over time. So I think the best we can do is actually hope for a diversified portfolio of different kinds of scientific performers operating under different kinds of incentives and funding models in different kinds of institutions with very different risk profiles. And it's good that we have some people kind of in the incremental, sort of curiosity-driven model, but I would also like to see kind of more swings on big high-risk, high-reward. I sometimes worry that our scientific financial portfolio, so to speak, is like 80% invested in bonds. You want to have some bonds in your portfolio, but you want to, if you're trying to optimize your long-run returns, you want it to be much more diversified.
We don't have a ton of time left, but we're all obviously very excited about this moment in time. This seems to be a rare convergence of both like technical opportunity and political wins. But both, especially the political wins, can be very fleeting. And it seems like for these bets to pay off, we still need like a lot more focused, durable attention here. So what would you recommend to policymakers? What are you trying to do in your own work to make sure that the efforts that we're making to like build the future of American science are durable, are not just like a flash in the pan, and then it's like, oh, that was just a phase. We're going back to the normal way. How do we institutionalize this sort of new creative approach to doing science?
Well, I think the risk here is that these new efforts don't generate the returns that policymakers expect in the timeframes that they expect. So breakthroughs can take time, but moving out expeditiously and getting RFIs out, getting requests for proposals out, getting money out the door, getting teams on contract, shows progress and momentum, and so I've been really encouraged to see that for all of the efforts that we've talked about today. So I think if we can keep pressing on that, then I think there's a good chance that that'll be sustained. But we do have to acknowledge that breakthroughs take time. And just one quick example, DARPA does this award every year for a previous program manager, and it's like a breakthrough award for but it's someone who did something like 10 years ago. And so, getting to this portfolio idea, we don't know what tools are going to be needed at the time. So when, Dan Wattendorf got this award a couple years ago for the work that he had done on mRNA vaccines, at the time we couldn't know the impact of that, but then that tool was available in the toolkit when we needed it.
I'm not going to talk my book, something different than FROs. I think that if you look back at the 60s, and the 50s and 60s, there's a really clear social contract between scientists and the public. And there was this sense of like, everyone was contributing to the same good, and there was an understanding of why it was moving forward, and there was a lot of buy-in in the scientific agenda. I think that social contract has somehow disappeared in the last 15, 20 years. And I think it makes it really hard for scientists, it makes it really hard for the public. I think that science has retreated into the ivory tower and stopped engaging and grasping the imagination and the hope for the future, and the public stopped putting their trust in scientists. And I think that this, is a apolitical, a bipartisan problem of how do you rebuild that connection and that trust.
Yeah, I think to maybe bring together some of these threads, Anastasia and I are sometimes on panels like this, and we have conversations and luncheons, and I think like a common phrase that just keeps coming up is that what we should be aiming for is more different science. We're really excited about the science we have, and we absolutely want more of it, but we also want to see that diversified portfolio. I want to see more innovation prizes. I want to see more advanced market commitments. I want to see more small-scale hobbyist science. I want to see more large-scale industrial science. I want to see more team-based. I want to see more infrastructure. There's just like so many different dimensions on which we could be changing and trying out new different kinds of scientific models, and I'm kind of like, let 1,000 flowers bloom, especially in a period where you have this general purpose technology and AI kind of radically changing what the underlying productive structure looks like. We should have a lot of uncertainty about what the best model is going to look like, and I think we want to place our bets pretty widely. But at the same time, I think that has to be paired with a really rigorous kind of commitment to evaluation and to hypothesis generation, and that like we don't actually know what the answers are going to be. And I think sometimes policy movements can get out ahead of their skis if they sort of like over-anchor on any one particular model and they say, this is going to be the answer, and then it doesn't end up working, and kind of the public or you lose faith from policymakers. And so I think we should acknowledge what we know and what we don't know, but have this kind of like simultaneous dedication to trying radically new models, and then also being really rigorous about measuring them.
So that was a great way to wrap up, but I'm told we have a few more minutes, and I'm going to take advantage of this to do another question. And sorry for going out of order. We have touched on this a little bit in all of your answers. We are also like figuring out a lot new ways to not just like partner and like build new teams and approach science from different angles, but like the people involved in the decision making is different, right? The tech labs, NSF traditionally funds academic research, are funding things that very much don't look like academic research. Genesis mission is about empowering like these really creative new kinds of public-private partnerships between like national labs, which have often very much like done their own thing, and the private sector. Renaissance Philanthropy is a philanthropic organization who's training people to be like DARPA program managers. There's a lot of cross-pollination that has not existed before. What do you view as like the unidentified upside of all of this, right? Like there's more people that are in this pipeline that traditionally were siloed. What does that more than some of its parts kind of thing create for you all?
I'll give a very kind of in the weeds example of actually how science is getting done. We bring in these CEOs who often came out of academia, and I will be like, okay guys, you have to build a data platform. Don't hire a postdoc to write your software. And they're all like, sure. And they hire a postdoc to write their software. And then they move really slow, and they're like, oh, I understand. My postdoc is not a like meta engineer. I should have hired somebody from Meta to write my software. And the thing is that like if you just spend your life in academia, you only see academia. And the same thing's true about industry. If you always have to chase like a very specific revenue goal, you don't get to be creative and you don't get to explore the same way. So even on like the not high level, the individuals interacting with each other more, I think that it trains people and inspires more ambition and more creativity and more growth.
Yeah, I think kind of building on that point, one thing I'm excited about in terms of seeing like a larger ecosystem of different kinds of institutions and organizations exist is that from the perspective of kind of an individual scientist, or maybe even not a scientist, but an engineer who wants to kind of contribute to the scientific enterprise, the more that there is sort of like a wide variety of different kinds of paths available to you, especially outside of traditional academia, the more it becomes possible to even imagine what it might look like to exit from the system. I think currently there's sort of like a deep fear that, well, if I like give up my tenure, cushy tenure track job, like what happens if this FRO kind of like fails or bottoms out? But the more that there are a whole diversity of different kinds of institutions, philanthropically funded, federally funded, privately funded, attacking the problem from a variety of different angles, it becomes actually less risky to imagine what it looks like to kind of go into this parallel track. And so each time that there's kind of a new infusion of new institutions that exist in almost this parallel to academia track, and actually I would love to see more back and forth, people going back from industry into academia, but I think it would be much healthier from a sort of career pipeline perspective if it doesn't seem like if I at all deviate from this path, I'm kind of permanently giving up option value.
To bring it back to AI, this happens all of the time in ML research. There is like a revolving door between academia and the labs and tech companies that is not true other places in science. And it is one of the reasons I think that AI has been able to accelerate so quickly is that people move between these different organizations. They're not totally siloed from each other.
Yeah, and I think what helps people, especially early stage people, identify these other pathways and move along them is developing this community. So not just new institutions, new models that they can plug into, but the personal connections and knowing people who've done this before and knowing people who've navigated that pathway, and then people who have done this kind of passing down that knowledge and serving as mentors. So this is something that we're really striving to do, is knit these communities together and help them kind of bring each other along on their career pathways. And so now we have people still in graduate school in our recent cohorts who are being mentored by people who have done something different, who have worked in a focused research organization or an ARPA type organization, and show them what's possible and help them figure out how to get there.